Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at coding in a virtual world. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make those tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight, we're really lucky to be joined by our two panelists, Paul Alves and Tom Stanke. Paul is the Department Head of Math and Computer Science at North Park SS, just outside Toronto in lovely Brampton, Ontario. Paul just completed his second term as President of the Ontario Association for Mathematics Education, and he is currently pursuing his master's in the socio-cultural context of mathematics education. Paul has presented at local and national conferences and has been a T-Cube national instructor since the year the first iPhone was introduced. Paul is an avid user of technology in the classroom and is especially interested in exploring coding as a vehicle to improve mathematical literacy. Paul, it's great to have you with us tonight.
Thanks, Mike. Great to be here. Thank you.
And Tom grew up in Toronto, attending a music school, then became an engineer, and finally found his passion in teaching and learning mathematics. For 28 years, he served as a teacher, department head, math consultant, T-Cubed instructor, and now as the TI Educational Technology Consultant for all of Canada. He loves how the T-Cubed community and TI technology has been a continuous source of inspiration and growth in his professional practice. Tom, thanks for joining us tonight.
Thanks, Mike. Happy to be here.
We're expecting a large crowd, so feel free to send any questions to Tom or Paul using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance, as well as a link for the documents at the conclusion of the webinar. We hope you don't have any audio issues, but if you do, try toggling your audio broadcast on and off at the bottom of your screen. At this point, Tom is going to discuss our agenda.
So we're going to start by reviewing the origin story of the online learning journey that Paul, myself, and a couple of hundred students from across Canada went on. We'll go over the design and implementation of the coding activities that were conceived of, and then we'll share what we learned from going through those experiences, delivering those online coding workshops. And I guess we'll end up with a webinar draw. Back over to you, Mike.
Thanks so much. Yeah, stick around to the end. One lucky winner will receive a T-Cubed International Conference registration. And Paul is going to discuss our expected outcomes.
Thanks, Mike. Yeah. So our hope is over the next hour or so that you're going to be able to, one of the outcomes is I can plan and deliver online remote learning for a range of learners for coding and physical computing. So hopefully some of the things we share with you will allow you to kind of achieve that. And then I can use strategies to engage students and optimize student learning online. Yeah, so hopefully by the end of it, we've kind of hit those two outcomes.
Paul, thanks so much. I just gave you control. Feel free to share your screen.
Awesome. Thank you. Thank you, Mike. Thanks for guiding us through this, being our technical help and being our host here. And welcome, everybody. So welcome wherever you are. Hopefully you're safe and things are going well during this time. So I've got a slide deck, and there's going to be a lot of balls in the air here. So hopefully things run super well on our end. And there are a couple of videos that are going to be we're going to play through the slide through at different points in our in our presentation. And so I'm going to throw the ball over to Tom at those moments, and he's going to play the videos for us, and then he'll flip it back to me, and we're going to we'll go through and again try to achieve those expected outcomes that we were talking about. So a lot of stuff that we want to share about our own journey, as Tom mentioned, what we went through in this past summer in 2020, and some of the lessons we learned, and hopefully some of the things we can share with you for those of you who are considering this or are living it as well at this moment. Just again, don't want to go through the introductions again, but if you do want to note our contact information, we will be sharing all of the resources that we highlight over the next little bit with you at the end, and we'll show you how to grab those. But if you do have any specific questions, anything in particular that you want to reach out and talk to us about, invite you to make note of our email address is available there, and I put in our Twitter handles there as well. If you want to message us that way, that'd be great too. All right. Now, I know we've talked about the agenda and the goals already, but maybe just allowing you, we're going to try to also allow some opportunities to engage online, and I think that's an important part of this. I think a lot of us in the last few months have had that experience of engaging students online and trying to keep kids engaged in that from a distance. So whenever you see that icon with that little chat pod there, that I'd invite you to share your thoughts there. So in the chat pod, and Tom and Mike are going to monitor that for me because I've got a couple of monitors going here. And so our goals, again, we're going to review a specific partnership that are kind of organically grew up between two organizations, Texas Instruments TI and Shad Canada, and we'll talk about what exactly that was and where that came from. I think it's important to kind of have some of that context before we kind of jump into what exactly happened in the summer and some of the things that we learned and went through. We're going to look at, and overall, we're going to look at the design and creation of those activities, how we set it up, and we're going to look at specifically a couple of activities that we engaged with the students, and those activities were designed for a range of learners, not necessarily your expert coder. They were meant to kind of engage all levels of learners in coding and physical computing. And then we're going to talk about some of the reflections we had when we look back on the things that we did, some of the things that worked really well, and hopefully share those with you, and maybe there's something to be garnered on your end to help you. But also we'd be really curious if you've heard, if there's something that you'd like to share with us, that would be fantastic, because more than likely we probably will have to do this again this coming summer, and so there's definitely some lessons that we learned too as well, and we'll share those with you as well. So I'd invite you at this moment, if you haven't already, please share in the chat pod, what is that platform that you're more comfortable using in your own teaching? So is it the 384 family or an Nspire family? So I'll give you a moment to share that with us. Okay.
And Paul, while everyone's typing that into the chat, I just want to remind everyone, please send your chats to everyone. So whenever you go to send your chats, there's like a send to drop down. And the default may not be everyone. It might be all attendees, but if you could select everyone that way, all of us have a chance to see everyone's responses. Thanks.
Thanks, Mike. Absolutely, yeah. I think most people are sending it to everybody. You see a lot of responses, predominantly 83, 84 users, but a few Nspire users sprinkled in there, which is great. Even though our lived experience was around Nspire, we will share. Again, I think this isn't just about a specific platform. It's about addressing some of the things that we learned in trying to teach coding from a distance and some of those strategies, and I don't think it matters what platform you're using. But Tom will also share some things at the back end specifically to highlight what how we've taken some of these activities and modified them and adapted them for the that 84 environment as well. Thank you for everybody for throwing that in the chat pod. And that just to comment on that photo there too. This is actually a photo from the actual one of the sessions that ran in the summer, and you can see I was sharing my my software screen, and these are some of the students that were engaging in the learning online and the chat pod. We were using Google Meet as our platform of choice. That was the one that Shad was using. But again, I don't think it matters what platform you're very comfortable with. I think these all the things we'll talk about are not really dependent on platform. They're malleable to whatever you're using in your own teaching. So just again, to talk about that context and where things had come from. So a couple of years ago in 2018 in the summer, Texas Instruments was approached, and this partnership organically grew between Shad Canada and TI. And so what exactly is Shad? Shad is an enrichment program that's available to grade 11 students here in Canada. And so that would be kind of the junior year in high school, and so they're predominantly 16-year-olds. And the program itself runs in the summer at university campuses across Canada. Runs usually for 4 weeks, and the students get an opportunity to participate in a variety of enrichment opportunities, things that you wouldn't necessarily see available in the high school curriculum. And so TI was invited to design a day of learning in 2018. And so an important the ETC at the time, Daryl Marchand, really kind of started this, and so we designed a day where where each of the classes got an opportunity to engage with some learning, especially around coding and some physical computing. And I think the engagement from the students and how well things went in that first year allowed us to expand the program. A lot of the sites that didn't participate in that first year heard about how engaged students were in that. They asked if they could be added in the second year in 2019, in the summer of 2019. And so we got an opportunity to expand the program to 480 students, go to 8 different university campuses during the summer in 2019, all the way from BC on the west coast out to Mount Allison on the east coast. And so, again, went really well, a lot of engagement, a lot of learning, and so we were excited to continue that. And now the actual design of these, so what exactly went into this, and so we're kind of starting to talk a little bit about the activities. The whole day consisted around these 2 3-hour workshops, and each of those 3 hours were designed for each of the 2 cohorts on campus at the time. So there were about 60 students on campus, and so they were split up into 2 groups, and each one of them had an opportunity to participate in a 3-hour workshop. The workshop was broken up into 3 broad areas. So we tried to design the workshop with the mindset that we wanted to have low floor, very accessible to students regardless of their experience with coding, but also make it challenging enough that those students who are comfortable coding can do things and take it where they want it to go. So it started off with just a basic introduction to coding challenge, and the specific challenge was around a simple program that determined the sum of the angles in a polygon. So a nice connection to some of the math curriculum that these kids have engaged with, but it also got them introduced to the coding on their handhelds. Once we had an opportunity to just get comfortable with the coding, we then introduced the Innovator Hub. And they worked through a couple of tasks. One of them allowed them to access the sound features on the hub, and the other one allowed them to program the color, the onboard LED, the RGB LED. And then the final portion was focused on the rover. And so students were challenged to draw the polygon from the very first activity that we did with the coding. And then they were challenged to create a design of their own. And they were invited to share that with the entire group. Now, the 2 photos that I'm showing you there, one of them is the one of the Innovator Hub activities, a STEM task that we used that really went well. It was the 4-chamber heart activity, and so students modeled the flow of blood through the 4-chamber heart using the Innovator Hub, and so there was an LED in each of the chambers, and it would light up according to the flow of blood through the heart, and so it was really engaging. Kids had a lot of opportunity to build, put something together, and get it to work with the code provided. And then the second picture is the kids getting into the coding of their design using the rover, and that usually took usually we had to tell them, we're done, your 3 hours is up, it's time to move to lunch, or the day is done. It was a lot of yeah, the whitebooks are a great tool. They go to Whitebook, I believe whitebook.com, and they're a great tool. They were indispensable for the work we did and also the work we do in the classroom as well. Now, at the end of the workshop, we're going to share some of the resources that we created in 2018 and in 2019. So if you're really curious to see, okay, what the 4-chamber heart activity or some of the things we did around the rover activities, you can find those there, but you'll also find all the activities we created in this past summer when we went to, which is what we want to kind of delve into next. Now, again, what came out of 2019 in that summer, there was a great amount of engagement. I think students were introduced and exposed to coding that had never had that opportunity before. So what I'm going to do now is I'm going to turn this over to Tom, and he's going to play a video that highlights some of the feedback we received from the students who participated in the program. All right, Tom, the ball is over to you, sir.
Hey, Tom, you're muted.
Tom?
Hey, Tom, I'm going to unmute you.
Okay.
There we go.
Here we go. Okay, are you guys seeing the black screen right now?
Nope, I see the girls in STEM.
Okay, perfect. Okay.
I'm from Vaughan, Ontario. I also am the vice president of my school's robotics team. Our robotics team is comprised mostly of boys. Not many girls are into coding or design for that matter, but when I got here, I saw so many more girls who are just like me, coders, business kids, everything. Shad had much more diversity in terms of skill sets that girls had, as well as really pinpointing those certain areas in which we can grow. I would recommend this program to anyone who has a passion for science, but not just science. It's also about being able to embrace teamwork, about increasing your collaborative skills, being able to become a well-rounded person.
Great. Thanks, Tom. You can throw it back over. That'd be great. Thank you.
Just a quick, Mike, can you move the ball over? It's just something went wonky kind of on my screen here. So are you able to move the ball back over to Paul? Thanks.
Sure can.
Awesome. Thanks, Mike. Okay. All right. Mike, are we looking at the slide deck? Can you just confirm that for me, please?
It's not quite showing yet, Paul.
Oh, sorry. Okay, let me try that again.
I think you're showing the, yep, there it is.
Yep.
That's.
Hold on a sec. Here it is. Perfect. There.
No, that's still the presenter view, I think. So it's the wrong screen, I think, Paul.
Yeah, just one second.
Okay.
Sorry, everybody. I'll just get that. There we go. There we go. Perfect. Get that. All right. Why is that?
There you go. You just got to go over to the next tab. I think a remote possibilities on the next one.
Oh, that's, wow, this is, okay, let me try that again. There we go. Okay, perfect. Okay, there we go. All right, awesome. All right, sorry about that, everyone. Just getting everything. So again, I think the exciting thing for us was the engagement. Was the engagement that we got from students, and especially students who maybe this was their first experience in coding. And so the plan for 2020 was that we were going to go to 16 campuses, double the number of campuses that we had in the previous year. But of course, the pandemic hits, and we have to pivot and figure out what we're going to do, and if we can deliver this content at all within a remote model, with a remote learning model. And so we still wanted to provide these coding opportunities to students, but how we were going to pivot to that, and how that was the challenge, is how are you actually going to do it. And so what I'd like you to do is, and especially since I think we're all kind of living this experience at this moment, is what do you anticipate are some of the challenges especially when you're trying to teach coding remotely? So maybe in the chat pod, just think about some of the things and some of those obstacles and some of those challenges that you would have to address as a teacher if you're going to be teaching coding remotely. Tom, can you see the chat pod?
I can, yeah.
Okay, so great, fantastic.
They're coming fast and furious. So
awesome.
If a student's coding on a handheld, it would be difficult not to be able to look at their screens with them. Mm-hmm. Troubleshooting, debugging, being a hands-on facilitator, seeing their code. So this idea of seeing is an important one. Having a curriculum that meets the needs of students. Individual help, since students may be at several different levels. The idea of debugging and connectivity, consistent internet and tech, inability to have hands-on collaboration. So
I think, there's many of these, like the troubleshooting, debugging, like many of these
there's a good one here too. Carol says getting equipment to and from students.
Yeah, I noticed that too. So the big one, addressing those troubleshooting, debugging. How do you do that? That idea of getting the equipment and resources to students in a timely manner and making sure. So that's something we kind of thought through too. But also the idea of trying to. I notice a few people mentioning this idea of tasks and making sure you're differentiating, and you've got students at different levels, different familiarity, different comfort levels with coding. And I noticed, Sonia said something that really resonated with me, this idea of learning at first. I think, and I guess maybe that also comes from an idea, as teachers, we want to feel like we have a good understanding of the content before we lead our class through it or teach students, and we want to feel that sense of mastery. I'm not I'm not an expert coder by any means. A lot of what I've done is through kind of trial and error learning with students as well. And so there is a sense that sometimes you've got to recognize that many of the students, quite a few of the students that you might be working with have a depth of knowledge that could be just as deep as what you have in terms of coding. The hands-on activities, that's a good one too. So this idea of trying to engage students at different learners, oh, that's a great one, Brad. Yeah, this idea, and we'll talk about that too. Yeah, the Cesar, that idea. We'll mention, there's a few things that we can mention in terms of helping yourself kind of get up to speed, and going back to Sonia's point about feeling like learning it first. There's a few things that I can suggest as well that I've kind of worked through to feel like I've improved my own knowledge base as a coder and as a teacher of coding as well. Again, my background is that I teach math primarily, but I see coding as a way to reinforce the mathematics that my students are learning. And usually a common sentiment that my students will hear from me is, I say to them, if you can code it, you know it. And so that goes for all sorts of things that we do in the math classroom, sometimes some pretty mundane tasks, but sometimes some pretty challenging tasks as well. And that's a part of the challenge too, is finding those tasks that do allow for that breadth of challenge for all those different, that wide swath of learners that we do have. All right, so thank you for sharing all that. So many of these things are some of the things we started to anticipate too as we started to get ready for the remote experience in 2020. And so quickly, we had a team of 5, and so Tom, myself, and 3 others were part of this as well. And we designed these 2 virtual field trips. And so the team of 5 was responsible for designing them, creating them, and implementing these 2 virtual field trips. And so there was a group of users and students who requested to be a part of the first field trip, and you can see there were 310. And then a subset of that group was sent equipment for the second field trip that was around physical computing with the Innovator Hub. And so those had to be shipped to them, and so Tom was instrumental in getting a lot of that to the students. And we had to have a schedule to address who's teaching what, when, and which students, and so on. And so it was the logistics of it required a fair bit of teamwork and coordination between the students, the folks at the organizing at Shad, and then obviously with us as well. And so thinking of your own experience as a teacher, that initial experience of the planning, the setup, that groundwork that has to be put in place to make this run as seamlessly as possible, but also expecting it isn't going to be perfect, that you will run into issues. And so be fully aware that that will happen, no matter how well, and I think we did a great job of trying to anticipate these as much as possible, but there were still things that popped up that you just can't you can't plan for everything. So let's delve a little closer. We're going to kind of zoom in a little closer on the virtual field trips, and then we're going a little closer again, and we're going to look at a couple of specific activities that were offered in each of the field trips, and talking about the coding that the students actually experienced in those 2 field trips. And then talk about some of those things we've learned. And again, some of you have already mentioned a few of those things that in those kind of anticipations and some of what we anticipate and some of those obstacles. So the focus of the first field trip, and again, this was for the larger group of students, was primarily just on coding. So each of the field trips was designed to be a 1-hour online. The first field trip required students to do a pre-session activity that involved installing the software, a basic understanding of navigating the software, and a simple debugging exercise. So a little bit of coding that was primarily, here's a program, but it's not running, it's not doing exactly what you want it to do. Try to figure out what's going on. Now, during the 1-hour session, the students worked through 2 coding challenges once they went through it, the pre-session, and that was the FizzBuzz activity, which we'll delve into in a bit, and the rock, paper, scissors activity. Now, the session also The second field trip involved the use of the Innovator Hub, and so that required us to get the equipment to the students. This session also had some preliminary work, and that focused on attaching the hub, making sure they knew how to do that, and running some simple programs to see that it does produce sound, that it does light up the appropriate LEDs and the lights and so on and so forth. The session itself, once we got into the actual session, all that stuff, again, the pre-session was something that we expected the kids to do prior to engaging in the online learning. The session itself, we ran three coding challenges, the traffic light activity, which I'll talk about in a little bit more depth, the sound of music activity, and then lastly, we connected back to the FizzBuzz activity from Virtual Field Trip 1, which was, we called it Hubba Bubba FizzBuzz. But it was really just adding lights and sound to FizzBuzz once we knew how to code FizzBuzz. So that was the overall framework of the two field trips. Now I'm going to kind of delve a little, so it's kind of like this bird's eye view of, okay, how do we get our heads around doing this, and what are all those obstacles and logistics that we have to plan for, then the actual design of the two field trips, and now we're going to zoom in a little further and just see what exactly were some of these coding activities that we engaged in with the students. And so the first one, and this might be one that you're quite familiar with, it's FizzBuzz. It's a pretty common coding challenge. It's actually also available as one of the 10 minutes of code activities using Python on the TI site, so you might have seen it there, and that's actually, again, looking at some of the chat. Some people are looking for, places that you can go to learn coding. I'd invite you to check out the 10 minutes of code, and depending on what your platform is, the 8384 user or the Nspire user, pick the appropriate platform, but you can also get coding in TI Basic, which is what the kids engaged in primarily, but you can also get coding and learn a little bit of coding with the Python modules that are available there. They're excellent, really well-paced, different modules with an application at the back end. There's also some activities available through the TI site that are STEM challenges as well, so get a little bit of engineering challenges for the kids to actually build something and do something that way.
This is a pretty able group. I'm seeing a lot of 8, 7, 9.
Wow. Okay.
Like there is a 1, but it sounds like we've got some people that have some coding skills here.
Excellent. Great. And again, like if I was to put myself on a scale, I don't think I'd be a 9. I'd maybe be I'd probably be maybe higher than a 5, maybe 7-ish, I'd say. But again, the challenges and the tasks that we selected for the students were designed to be, again, low floor for those learners, but also allow them to take it to places that we really didn't anticipate as well. So there was a lot of things that the kids... To
build off that a little bit, the idea of low floor, there's 2 dimensions to low floor, really. There's the mathematical, like in the math world, we have this idea of low floor, high ceiling too.
Yeah.
So the mathematics is low floor, but the technical skills are low floor too. So the technology, the coding, like the coding that you need to know. So the assumption is a 0 is what Paul created this with. He assumed that we're going to start kind of from the assumption that everyone's starting at 0.
Yeah, that's an excellent point, Tom. Yeah, that the assumption coming in for the learner was that they had never coded before, and also there was an insistence. And it was obviously easier in person, but we also had a lot of success online in the remote experience. The insistence of we are not moving forward unless everybody moves forward. And so there are a lot of built-in opportunities for check-ins to make sure that students could show us and demonstrate to us that they had met these appropriate moments to check in. Have you done this? Have you experienced success? But also, if you hadn't, we had built in these opportunities to address that as well. And that's, again, some of the things that, like mentioned in some of the challenges, some of the things that we thought about in advance that we wanted to try to say, what if a student gets off track? What if they get sidetracked? What if somehow the technology doesn't behave? And so we tried to address that as well. And again, I'll try to mention that at the back end here too. Now, FizzBuzz, I think, it's my favorite coding activity because the math, and as Tom just said, mathematically it's low floor, but also coding-wise it's low floor as well. But it really builds in a lot of the logic that you would need for coding, but also some of the programming structures you would need as well. So the rules, and you can see them on the screen, it's just a basic counting game. And I think it's really important, even online, to play the game without any coding. And so what we had the student names in advance, so the student rosters, and we used a program, of course, to randomly pick a student from the class list, and then we asked them to continue the count. So I would start off with 1, and then I'd randomly pick a kid, and they'd have to give me the next number, and we'd see if we could replicate this idea of FizzBuzz with live counting. And so, again, I think that's really important to do because the way that the process highlighted in the thinking of counting it is what we want to get the code to mimic. And a lot of the things that they think are exactly the types of structures we want to build into the program. And so we're going to examine the code on the next slides, but before we do that, well, you've already answered that, but we're going to take a look at the actual code that the students engage with and how we built the activities to try to maximize and optimize student engagement, student learning, and try to, again, not alienate those novice coders that were in the group as well. So we scaffolded the actual activity starting with what we thought was the most important thing to start with is, can you just mimic and replicate the process of counting with code? And so in the top right here, the graphic in the top right is the skeleton or the base code that students were provided with, and they had to replace the question marks just to get the simple counting experience to occur. And so then what we did is then we said, okay, now you know how to create code that produces counting using a for loop. We want to add in this layer, okay, replace the 3s with the word fizz. And so we talked about what structures we would need, where should that go in the code, and then what should it look like. And so they added that into their code. And then then we slowly built that up. We went to Buzz, and that was pretty straightforward and intuitive. And then finally, okay, let's add all those pieces together, and let's create FizzBuzz. Now, the code was provided to students in advance with all those pieces missing, and they just had to, again, replace the question marks with the appropriate values. They were then instructed to run it, see if it worked, and again, in all instances, we asked students to contribute their work so to our collective understanding. I really tried to not move forward until someone else told me what I needed to do to complete the code. So sometimes there wasn't a ton of silence. The kids were really engaged. And again, I think it was a big part of that was creating a task that was engaging and challenging, but also, again, that had that accessibility for all students. We insisted that all cameras were on and that kids unmuted themselves whenever they wanted to contribute to the collective understanding within the online environment. And there's things that you can do, and I know in my own experience right now teaching math, cameras on is a challenge. Many with the high schoolers, but there's a lot of things you can do to build culture and even some games that you can do to play with students online to kind of get them to have the cameras on. And there's some strategies there that you can kind of engage with the students to kind of promote the idea of cameras on. And I think it also just builds a lot of engagement too if kids have the cameras on as well. So what I'm going to share on the next screen, though, and we're going to see if you can kind of figure out, again, no matter where you are here, 1 to 9 or 10, doesn't matter. I'm going to share with you the final FizzBuzz program. So this is what they should have had at the end, but it's missing some pieces. And so there will be a prompt for you to engage in the chat pod here, and let's see what you come up with here, because there was an opportunity here for students to really think about what they wanted the program to do and what it ended up doing. So here's what it looked like. So before you throw it in chat pod, if you could let's just examine what I've got here. So it's going to ask the user to tell to what number do you want to count to. We usually encourage the kids to at least count to 15 so that they can see a full fizz-buzz cycle, right? Because fizz-buzz should happen at a multiple of 3 and 5. So we request that kind of upper limit from the user. And then we've got our for loop, and we're testing the each number each time. You could use the mod function here too. For those of you who are 9s, there is a mod function. I'm sure you're familiar with that. There's actually even something cooler in Python that replicates the mod function, but there's also a remainder function in TI Basic that you can use. So there's a whole bunch of options you have here. But you notice that I've got some question marks here. So what I'd invite you to do, and focus, like the display, what I'd really like you to do is focus on what goes in the parentheses here beside the letter I. What would you say replaces those 3 question marks in the remain statements so I can get this code to work? So go ahead and throw that in the chat pod. So imagine what's happening here. We're going to get the user to input the upper limit. So let's just say it's 15. So this for loop is going to execute starting at 1, and it's going to go up to 15. Just like we were counting, okay? So it starts at 1, and should it display fizz, buzz, or just a number? And then it'll go to 2, 3, 4, 5, and all the way up to 15, and we want to display the appropriate value or the word at the appropriate at that time. And so what should replace those 3 question marks in the remain statements? So what do you think?
So we're seeing quite a few 3, 5, 15 kind of that order.
I got a couple there. So 3, 5, 15 for Miko, 3 for thank
Becky,
you, Becky. Yeah, 3. Okay, so perfect. 2.3.
2.35, Charles. Yeah.
So Rohit, he's got 3 first, then okay. Thank you, Rohit. I saw that ballot. Okay, perfect. So okay, now Jenny, that's interesting. You've got a different order, I'm noticing, but Deb, you've got 3. Okay, so this is great. So let's just see. This is exactly what happened in our coding challenges online. The very polite crowd online tonight. This is exactly what happened in our coding challenges online. So what I'm going to do is I'm going to flip over to my software and do exactly what you suggested. I'm going to go 3, 5, 15. I know some of you suggested a different order, and so we'll maybe examine that. I've got Christine with a 15, 5, 3. Okay, so I've got to share a different application here, so bear with me. Let's see if this works well. And Tom, you chime in if smoke starts pouring out your end. So here we go. Okay.
Yep.
All right.
Seeing your
software. Okay. So what you're seeing. So I'm going to replace that first question mark with a 3, and we're going to replace that with we're going to display fizz. Great. And then we're going to go 5. It's always exciting watching someone type buzz. Okay. Is there an extra space in there? There we go. And then lastly, we want to display fizz buzz if the remainder is 0 when we divide by 15. Awesome. But if it's nothing, if none of that happens, we're going to display I. Okay, so again, just to try to get a sense of what is happening here. What's happening here is exactly what should have been going through your brain when we were counting. So we're counting from 1 to an upper limit defined by the user, say 15. If it's divisible by 3, say fizz. If it's divisible by 5, say buzz. If it's divisible by 15, say fizz buzz. And then if it's not any of those, then just display the number. So here we go. I think I'm going to store that. So I'm going to hit Control and B, and that stores the program. And then I got to hit Control R to run it. And I'm going to hit Enter to execute the program. What number do we want to count to? Here we go, 15. All right, fingers crossed. Nope. What's happened here? Oh, no. It froze on me, Tom. Hopefully it's...
Oh. Well,
No.
I mean, let's see kind of what see if there's any psychic people here. If this program were to run, do you think it would have run okay?
No, there it is, Tom. There it is. Perfect.
Oh, there
okay.
it is. Okay.
Perfect. It just took a second. I think a lot of stuff's happening. The bandwidth is being maximized.
Sonia says no, and Paul, if you look at the where in the output do you
Well,
find
it looks pretty good so far, doesn't it? 1, 2, 3 fizz, 4 buzz, 6 fizz, 7, 8 fizz. Looks promising. Buzz, that's 10, 11 fizz, 12, 13, 14. Here it is. No fizz. We did not get a fizz buzz. So, no worries, Linda. 15 is incorrect, according to Jenny and Sonia. The 15's incorrect. And so, again, like the program runs fine. Syntactically, it's running fine. But logically, it's not doing what we want it to do. So it kicks out when it's divisible by 3. Exactly, Sonia. So imagine when we were going through the last iteration of the for loop. It's gone. Remember, it worked well up to 14. Now imagine it's going through 15. It reaches this first if statement, and it says, yes, I'm divisible by 3, and it dumps out the fizz buzz rather than waiting until. So you're absolutely right. The order of my if statements matters here. So if I change the first one to 15 and modify it now this way, the 3 and 5 are inconsequential, right? The order of those two don't matter, but the order of the 15 is critical. So now if I save that, let's try running it here. Hopefully, Linda, it doesn't freeze on me. Okay, here we go. Let's count to 15 again. Oh, there it is. It went really quick. Didn't freeze on me. And it was successful. Perfect. And as exciting as that may seem or not seem, that was amazing online, and especially since kids had that experience that many of you kind of shared there, is they were expecting it to work. 3, 5, 15, and especially since we had scaffolded it, say, okay, first, I guess we kind of led them there too. We first code fizz, then code buzz, then code the fizz buzz, and so they decided, oh, well, just add it on, and it kind of made logical sense. But the actual program running didn't produce what it does. And so, and again, someone mentioned that the idea of debugging. Those are important moments. I think it doesn't matter what class you're in. Those opportunities to really dig deep and say, why didn't something happen that you expected to happen? So FizzBuzz, again, that went really well with the students. And again, I think it really allowed students, regardless of their coding experience, to really engage with that and really have some feeling of success and accomplishment when they had that done. I'll talk quickly about the second field trip and the coding a traffic light. I thought this was a fantastic one. This was actually developed by one of the other one of the other contributors to it, Chris Atkinson, developed this, and so we all collaborated, but he did a great job of creating this one. And the great thing I loved about it is he introduced modular programming and having programs using sub-programs within them. And so it was a really straightforward program. Yeah, absolutely. Absolutely. It connected to math. I think the thing I've always mentioned is to my students, again, say it again, if you can code it, you know it. And it allows students to really kind of get at their mathematical understanding, that mathematical literacy, one of the things I'm really curious about. And so the traffic light.
We're not seeing your screen right now, Paul.
Oh, no. Okay, sorry about that.
We're seeing a gray screen right now.
Oh, no. Okay, let me try that again. One sec, sir.
I'm sure none of you have had these experiences in all the online teaching that you've done this year, right?
Can you give me a thumbs up?
Flawlessly. It's beautiful now. Yeah.
Excellent. So the traffic light, perfect. So this is what it looked like. So the challenge for the students was we're going to use the onboard color LED to mimic the function of a cycling traffic light. And so the first part was programming the onboard LED. So they were required to write 4 separate programs for the red, yellow, green, and then turning the light off. And so the students were required to, and then so the color, that set color command for the hub requires 3 arguments. And so does anybody know what should I put in if I want it to be red? Anybody know? Throw it in the chat pod if you know. It's an RGB, kind of 3 arguments are needed. If I want it to be red, perfect. Thank you, Jenny. The maximum value is 255. The lowest value is 0. So if I maximize the first number, I'm maximizing the red in the mix and minimizing green and blue. And so 25500, or another way to program it using the onboard LED is put the first argument as on, and then the last 2 is off, off. That accomplishes the same thing as well. So then we had the students go through again, they went through the programming of all the other lights as well. They're required to write 4 separate programs, and then they indicate the amount of red, green, and blue present. So, and it really was helpful if you have like an RGB color picker, and you can see here there's the red 25500 to help get the color mix correctly, especially for the yellow. Okay, that helped as well. The yellow should be a little mix of red and green to get the yellow right. I think it was 255, about 150-ish to get a good yellow there. So once the kids had all of the separate modules written, so the red, the yellow, and you can see the yellow, 255, 128, the green, and the off, okay, and you can see I've kind of mixed up the different ways you can actually program the color LED. You can use the numeric arguments, again, maximum 255, but you can also just program as on, off, off, or if you want them all off, no color, off, off, off. So once we had them, we wanted them to write a program. They had to write these 4 programs in a single document, and then they had to put everything together into a single program that requested how many times to loop through the light, how long will the red and green stay on, and so then we talked about the different types of loops you can use to get this completed. So you could use a for loop, a while loop. We talked about the advantages and disadvantages of each. And so notice that each program that they wrote, the red, the yellow, the green, and the off command, were called as sub-programs within this traffic light program. And so I think we ended up going with a for loop here based on how many times the user wanted to loop through the light. And here's what it looked like in the end. Let's see if this runs well. There's no sound here, so let's see how well it runs. Oops, sorry. Let's try that again. So there's a little bit of green. Goes to yellow for a second. I think that's red. Oh, sorry, the red is first, then yellow, then green, and then it should go off. It loops through twice. So simple program it built in a lot of the stuff with the physical program, but also this for loop, and also this idea of using modules or sub-programs within a larger program and being able to call those in. So, and again, going back to, so thinking about the results of all this, what came out of this, and we're going to start wrapping it up soon. And we were actually really surprised. Well, I think we overshot our expectations. The student engagement on the other end was just amazing. Kids were really engaged based on some of the feedback we got after the session, some of the stuff that was happening in the chat pod, what we were seeing on the camera, kids holding up their hubs to the camera to show how things were going on their end. It was I think it really kind of it blew us away how well things went, and we were really, I think we were a little apprehensive thinking about how things were going to go. And so we do, I think, Tom, we do have another video, but I don't know if we want to play it, if we want to just move to the
Yeah, I think let's just move on. Yeah.
Yeah. But this is just a young girl who got her one of her programs to work as well. So let me just go. So kind of the big learning from all this. So we're going to talk a little bit about some of the strategies that we think really worked well, and then maybe some of the challenges. And again, some of you had mentioned this already. So first of all, physical setup for you, for the student on their end. Space to spread out was critical. For me, and you can see I'm kind of got my attention on a second monitor, that really helped. So the monitor allowed me to focus on the meeting room, while the main workstation, my laptop, was on either the slide deck or on the software to allow me to code. So that logistically, that helped significantly. Teamwork, relying on someone else to assist with the design. We had a team to create the overall workshop design. So if you can have a colleague to think about tasks, implementation, that's critical. If you can, having more than one person during the session, and you can see Tom's helping me out with the chat pod, really helps out because, I think we're all experiencing this online learning experience, and I know even within my own teaching in math during the day, I have both monitors going, and you've got a lot of balls being juggled in the air using technology. And so if you do have someone else that can help you out, that's great. So that person can focus on addressing troubleshooting issues that we mentioned, but also looking at the chat as well. Lay the groundwork, and the groundwork is critical in terms of those pre-session materials that were created to allow the students to kind of get everything ready before we got into the activities. I think that was one of the biggest things that made things successful, is that we had all of those pre-session activities ready. So this is what you have to do to get ready, check this, check that, and here's a little bit of, can you find this on the screen, and can you make a very simple program? Can you decode a program as well? And then we've mentioned this already. Know your audience. If you do have that wide arrangement of ability levels, make sure you try to differentiate for that. And so that's really important. You think about the tasks that you're using. I don't think that experience of just watch me code then you do, I think it works a lot better if you have a good challenge for the kids, for them to try and to sink their teeth into. I think that's much more engaging than just watching you do and then do as I do. The bug, those were critical. As we saw with that one, with the FizzBuzz program, whether they're syntactical or logical, those were some of the best moments for learning for us. And that's true of all the experiences we've had with STEM and coding with the groups. And sometimes intentionally embedding those opportunities for collective discussion were invaluable. The handheld versus software. In our experience in 2020 was all software-based, which provides some pros, but some of the cons are the kids have to juggle multiple screens and tabs and so on. Whereas with the handheld, it was basically they could be watching what was happening in the online format, the online class, and then doing whatever it is on the handheld. So that is something to keep in mind, that you do gain something, even though the experience of actually coding on the handheld might be a little bit laborious, but there is something gained using a handheld for coding as well. Building that in online engagement culture, insist that learning takes place when everybody's engaged. Cameras on. Try to think of strategies to build this in. Like I remember I did one with my own class where we passed the pen. So I would have a pen and I'd pass it to a kid either above or below me in the grid in our online environment. It was a lot of fun, but it got them to start turning on their cameras. Insist on students do more talking than you. If possible, ask them to share their screens to highlight their thinking, depending on what platform you're doing. And I think I'm just going to finish off with some of the challenges and obstacles, and hopefully we'd address them. Yeah, thanks. The logistics of getting the equipment to students, critical. Can you set up a pickup and delivery? Be prepared for issues. You know it's going to happen. So just do your best, and also prep the class, and just so that they don't get too kind of to that they don't get too thrown off track by that. So think about things.
One thing I'll interject here, Paul.
Yeah.
The ones last year were an hour, 2 1-hour workshops.
Mm-hmm.
Today is 1 hour. And you can hear in Paul's voice, his cadence is getting quicker and quicker because he has to hurry up.
Yeah, and I've got the message. Yeah.
And I'll tell you, like, that when he says that allow mistakes to happen, you can't do that if you're rushed.
Yeah.
So this year, for summer 2021, 2-hour sessions.
Yeah.
And it's intentionally going to be more relaxed. So don't overload yourself is a huge thing.
Yeah, absolutely. And thanks. And then, how are the students getting the files? The KISS principle, the easier, the better. Just get it to them. And then the tasks. I can't stress that. And I think I've talked about it a few times. It shouldn't be about learning code. It should be about coding to learn. I cannot stress. That's when we've kind of hit that sweet spot for this experience. They're getting that coding, but they're really getting at some good critical thinking and problem-solving skills. I think the only thing we'll talk about and wrap it up is our resources. So this is linked, and Mike will have this as one of the documents that we shared with you, and this has links to everything that we've talked about, including stuff from years gone by, including some articles and some literature, and so much good stuff there. So if you're looking for anything that we didn't address, please check that resource page. It's a single PDF with everything you might need. But again, please reach out to us. We've kind of lived through this and learned a lot, but I think there's still some things we could have improved upon, and we're looking forward to doing it again this summer. Mike, I'll turn it over to you. I apologize for going a little bit over. Thanks, everyone.
Thanks so much. We're really excited that TCUBE International Conference is going virtual this year. To learn more information, please go ahead and visit our website. But as promised, we're giving away to one lucky winner tonight a TCUBE International Conference registration. And tonight's lucky winner is Charles Wolf. So, Charles, congratulations. We hope to see you, as well as everyone else, at the TCUBE International Conference. And, Charles, we'll be in touch over email in the next couple of days to give you some more information. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed as a link, as promised, for the documents from Paul and Tom for tonight. And if these links aren't working for you for any reason tonight, just hang tight. You'll automatically get a follow-up email in a couple days with those links, as well as a link to the recording. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Big thanks to Paul and Tom for everything they put together tonight. We really appreciate it. And thanks, everyone, for joining us. We hope to see you back online next week. Have a great night.
Thanks, everyone.